They move across the surface of seas, oceans, and rivers, etc. It's caused by the wind that on the surface produces drag created the waves, so the smooth force of the water is restored and again created a formation that is the tension and the gravity. The greater height of the waves, the greater amount of energy they have. The highest part of the wave is the crest and the lowest part is the trough. The amplitude is the distance from the equilibrium point to the crest. The wavelength is the length from crest to crest or trough to trough, and that is one cycle. The period of the wave is the time between the arrival of several consecutive crests at a specific and stationary point, and the propagation of the wave is the direction towards which the wave moves.
The main properties of waves. Amplitude is the height of the wave. The wavelength is the distance between adjacent crests. The period is the time it takes for one complete wave to pass a given point. The frequency is the number of complete waves that pass a point in a second. And the speed is the horizontal speed of a point on a wave as it propagates.
The sound spreads from one place to another, either through solid, liquid, or gaseous matter. Some examples are air, water, and wood. In the case of water or fluids, the sound propagates in the form of pressure fluctuations, and in the solids or wood, it propagates with variations of the tensional state. The sound propagates through different speeds, so an example can be that the speed of sound propagation is 1.4 meters per second in water and 3.6 meters per second in wood. Another simple examples are when the noise of a waterfall or a rock that falls through the floor.
The mechanical waves are propagated by the material medium. They can be the air, water, ropes, strings, soil, and welds, which causes a disturbance of the mechanical properties. There are two types. The transverse waves cause the medium to vibrate at the right angle, and the longitudinal wave causes the medium to vibrate parallel to the direction of the wave. Some examples are the sound, the seismic wave in the water, the wave in the string, like in the guitar.
In the image, we can see a comparative chart of a transverse wave and a longitudinal wave. The transverse wave happens when the particles in a medium vibrate perpendicular to the direction of the wave's motion, and the longitudinal happens when the particles in a medium vibrate in the same direction of the wave's motion. And for a transverse wave, the displacement of the medium is perpendicular to the direction of propagation of the wave. In the longitudinal, the displacement of the medium is parallel to the propagation of the wave. In this image, we can see two examples of transverse waves. In this other image, we can see examples of longitudinal waves.
Here we have the formulas to calculate the speed and the frequency of the waves.
First of all, for this part, we need to access the simulator. Now we select Oscillate in the checkbox as well as Fixed End and Slow Motion. We also need to check the boxes for rulers and timer. The tension needs to be high and the damping needs to be none. The frequency needs to be of 1.5 Hz and the amplitude needs to be of 1.50 centimeters. Now we need to know the length. We use the ruler for that and we measure the string, which gave us 7.5 centimeters of length. Now we are going to press start to the simulator and we are going to measure the time. we stopped it at 3.49 seconds. Now we select all the data and write it down in our table. We also need to count the nodes in it and write them as well. Now we need to restart the chronometer and we need to put the amplitude of 0.8 centimeters. Now we hit the restart button and we start the chronometer. We stop the chronometer at 3.52 seconds. Now again we count the nodes in it and we write down all the data we have for it. Now we change again the amplitude to 0.5 and we change the frequency to 1.8 hertz. We hit the restart button as well as the chronometer and we restart it again. Now we stop the motion after 3.5 seconds, and now as well as the others we count the number of nodes in it and we write it down in the table. And now with all the data we have, we calculate the speed and wavelength of each one of these times we use the simulator.
Now that we've put all the information in the table, we need to get the velocity and the wavelength. The formula for the wavelength is 2 times the length over the nodes. And the formula for velocity is wavelength by frequency. First of all, we need to get the wavelength. The first one is which give us a total of 3.75. The second one is the same, so it's going to give us the same results, which is 3.75. And the third one is with 5 nodes and give us a total of 3. Now that we have the wavelength, we need to get the velocity. So we do the next steps. Which gives us 5.625, which are the results for the first and the second. Now for the third one, we need to do 3 times 1.80, which give us a total of 5.4. Now that a table is complete, we can see all the results in here, which are in centimeters because that's how we made it.
In conclusion, this activity helps us to identify the characteristics of the waves in their parts, as well as to know how important they are, because thanks to them, we as humans can understand and discover the natural phenomena and know why of their existence. We also learn about the propagation of sound and its properties, which were the ones that help us obtain speed, intensity, frequency, and even handle it with harmonics.